Good day. Today we will be looking at algebra. Now, what is algebra? Algebra is like arithmetic. It uses the same operations, but algebra introduces the element of the unknown. Only unknown in arithmetic is the answer. For example, 1 plus 2 is equals to question mark, of which us being the clever mathematicians we are, we know the question mark there stands for the number 3, because 1 plus 2 is equals to 3. However, in algebra, 1 plus 2 is equals to x. Bear in mind, here you can have any letter of the alphabet, as this is simply a placeholder. Now, just to clarify, x is used as a placeholder for the unknown value. Now let us look at algebraic equations. It is a mathematical statement that says two things are equal. 1 plus 2 is equals to x. The left side is equals to the right side. Known value is equals to unknown value. The main goal of algebra is to find out what unknown values are and what they stand for. This process indeed is called solving the equation. Hence, finding what the unknown values stand for is called solving the equation. 1 plus 2 is equals to x. Therefore, the unknown value x is equals to 3, or 3 is equals to x. Now, as the rule of thumb with maths, there are some rules we have to follow. Algebra rules. Rule 1. Same symbol can be used for many algebra problems to stand for different values. Example 1. 1 plus 2 is equals to x. Therefore, 3 is equals to x. Very straightforward. Now, for a not so straightforward example, 5 plus x is equals to 10. X is equals to 10 minus 5, x is equals to 5. Let us see how this happened. As we can see in the first line here, 5 plus x is equals to 10. But you have an unknown value. You have a known value on the left-hand side and a known value on the right-hand side. For you to be able to solve this, you must have unknown values on one side and known values on the other side. So we must move this 5 across to be with the 10. But now something very strange here happens. As we move the 5 across, it now becomes negative. So it is safe to say the sign that is here changes when it goes across the equal sign. So if we had a negative sign here, for instance, this would now become positive and our x would now be 10 plus 5, which is 15. But here, our 5 is positive as there is nothing behind it. So when we move it to the other side, it becomes negative, giving us x is equals to 10 minus 5, which gives us x is equals to 5. Rule 2. Two or more values cannot be represented at the same time by the same symbol. For instance, x plus x is equals to 10. Now, can we say that 6 plus 4 is equals to 10 in this case? No, we cannot, because x cannot be equals to 6 and equals to 4 at the same time. It simply does not work. Why? Because here we are given the same symbol, we can assume that that symbol has one value, and that can be proven. If we add the number of x's we see, we get 2x is now equals to 10. And if we divide both sides by 2, we get x is equals to 5. But don't worry about this for now. For now, realize that because the symbols are the same, the value that they have is equal. Therefore, here, x is equals to 5, there and there, which is true because 5 plus 5 is equals to 10. However, here we have a different scenario. X plus y is equals to 10. Now here it is very okay to have different values because x and y themselves are already different letters, which satisfies the rule. Two or more values cannot be represented at the same time by the same symbol. So this would be correct. On to rule 3. Unknown values. Unknown values are dependent on each other. A variable is a value that changes depending on the value of the other. Let us look at this in more detail. With, of course, a few examples. Now, we are told a plus b is equals to 2. Now, these are very dependent on each other because at the end of the day, whatever answers we have in here should equal 2 because that is what the equation tells us. So, when a is 0, automatically we know b must be 2 in order to give us the answer 2. When a is 1, we already know b must also be 1, so that their addition gives us 2, and so on. Feel free to pause the video and look at these in a bit more detail. Now, of course, what would be mathematics without operations and operands? Arithmetic operations. Of course, we know we have addition, subtraction, multiplication, and division. Multiplication is a default operation if no arithmetic operation is present between the symbols. What do we mean by this? Take for instance here, A, B, with no operation in between them. Now, what we can do here is we automatically assume that they are indeed multiplying each other, and we bring the A and B together. This is a very useful technique in mathematics as it makes everything look much easier and smoother and just cleaner on the eye, avoiding messy work. So let us look at this example. A times B in brackets plus C times D brackets is equals to 10. To simplify this, we can simply write this as AB plus CD is equals to 10. Now, this can also be used for a variable and a known number. For instance, 2 times y is equals to 2y. Now, we need to be very careful when we use this rule with numbers, as it is slightly different. Take, for instance, 2 times 5. We know our answer of 2 times 5 to be 10, but now, unlike with the variables, we cannot simply put the number 2 and 5 next to each other, because that gives us a completely different answer. So therefore, this would be wrong, as we know 2 times 5 to be 10. On the next line, however, 2 times 5 is equals to 2 in brackets, next to it 5 in brackets. This implies multiplication, so this is indeed correct, as this gives us the answer 10. On the last line, 2 times 5 is equals to 2 in brackets 5, or 2 in brackets and 5. Now, we can see that these are exactly the same thing, and it does exactly what this line does. Its intention meaning to multiply the 2 and the 5, both giving us an answer of 10, both being very correct. That is all for today. Thank you for coming. Take care.